What is up, guys? It is Nick from Boost My ATAR, and today we're going to be looking at the very first dot point in the production of materials chemistry syllabus, and it says we need to identify the industrial source of ethylene from the cracking of some of the fractions of petroleum. So first of all, let's break down some of these words. Identify right here being the verb. All we need to do is simply just see what it is and reproduce that on the paper. So we don't need to explain anything, we just need to simply identify it. Basically, let's look at what petroleum is to start with. So we'll say what is petroleum? What is petroleum? So petroleum basically is this big, horrible mixture of different types of hydrocarbons. Now, a hydrocarbon is something that is simply made out of hydrogen and made out of carbon. So we can have relatively short hydrocarbons. So this is one here. Ooh, this one here is something you may have come across before. So this is ethane. Or we can have really, really long ones, you know, carbons and carbons and carbons long. So imagine that could be like 20 carbon atoms. 20, oh, I've gone off the screen. Anyway, we'll say this is 20 carbon atoms long along here. So, and there's everything in between, every length in between. So the key thing is to identify that petroleum is a mixture of different hydrocarbons. Now, we are concerned in this dot point with ethylene, also known as ethene. So those are two common names. So ethene is the proper name and ethylene is its common name. So now that we understand a little bit more about what petroleum is, that it's just a mixture of all these different hydrocarbons, we want to figure out what ethylene actually is. So ethylene, we'll say, what is ethylene for a second? So ethylene looks like this. It's pretty similar to ethane, except we've got a double bond in the middle. So we're looking like this. Okay, so this here is ethylene. Now, this double bond is important, and we'll speak of that importance in future videos. But basically, we want to understand properly how we can obtain this specific molecule from this big mixture of petroleum. And the dot point tells us about cracking, but we want to figure out and go into a little bit more detail about what cracking actually is. So here we're going to look at catalytic cracking. Now, catalytic cracking, here's a little definition here. Catalytic cracking is the process where high molecular weight fractions are broken down into lower molecular weights using high temperatures and zeolites. Now, this zeolite here is simply a catalyst. It's simply a catalyst. And if you want to be super specific, those zeolites are inorganic catalysts and are made out of things called aluminosilicates. But I don't ever think that we'll be requiring that much detail to answer a particular dot point. But you have a little bit of information about that anyway. So basically what we're going to do with catalytic cracking is raise this mixture of petroleum that we have to very high temperatures, and basically that is going to break down our long chains into smaller chains. And we can do that eventually until we obtain our desired product, which is ethylene. So here is an example of catalytic cracking. You may or may not be required to produce an example, but decane is usually a pretty easy one to remember, so commit this one to memory. We have decane in the conditions of a zeolite and high temperatures will break down into hexane and 2 molecules of ethylene. So that's the balanced equation for it. So all we're doing is we're heating part of the petroleum up. In this case, we're looking at a decane molecule, and we are simply producing molecules of lower molecular weights. And in order for our equation to be balanced, we're going to have more of these molecules with lower molecular weights being produced. So basically, that is a pretty quick overview of how ethylene is produced via the process of catalytic cracking. And we also have understood a little bit about what petroleum is. So just as a quick summary or overview, petroleum is a mixture of these hydrocarbons. So petroleum equals a mixture. Petroleum is a mixture of I'm about to go off the screen, carbons. Is a mixture of hydrocarbons, and all we're doing is using heat and a catalyst known as a zeolite to break down these large molecular weight fractions of petroleum into lower molecular weight fractions, because those are a little bit more useful in industry, and they're just a little bit more valuable to people who wish to make certain products. So we want small ones. We achieve that via the process of catalytic cracking. We used our example of decane, and we obtained this molecule here, which is ethylene. Now we should also note that there is another way to obtain this molecule via another cracking process. It's known as thermal or steam cracking, and basically instead of using a catalyst such as a zeolite, we just use very high temperatures, as well as something called a pyrolysis coil. But we won't worry about that. We'll just focus on catalytic cracking because that's what the syllabus wants us to know, and we will delve into this more in the next dot point.